All right, we got the fat twin here, 12.1. It's actually through 12.3. Let's see, I was going to teach Wednesday, but I decided not to because, well, you all need practice. All right, number one, 100 people enter a contest. First prize is a lifetime supply of chewing gum. Second prize is a subscription to Car and Driver magazine. Billy and Bobby, two good rednecks here, have each bought tickets. One of them wants Car and Driver. Let's see here. Find the probability that they both win either first or second. So there's two ways this can happen. Billy can be first, Bobby second, or, and hear me out, Bobby first and Billy second. So we have that word or show up. And we know by now, at least I hope we do, that or means add. So if Billy gets first place, there's 100 people. So it's a 1 in 100 chance. And then his ticket gets pulled. So times 1 over 99. Or vice versa, Bobby gets first, which is a 1 in 100 chance, times Billy, who now has a 1 in 99 chance. We just have to add these two things together. That's what we have to do. And I'm not going to sit here and bore you with this by hand. Nobody's going to do that. So let's go push some buttons. We got 1 over 100 times 1 over 99, which you could just double it and get the same thing. I could actually just multiply this by 2. But I have to actually add it back in. Granted, it's the same thing that happens twice, right? And I get this funny looking number. It's pretty tiny. I'd be surprised if your TI-84 could convert it to a fraction. Oh, it could. How about that? 1 in 4,950 chance of that happening. Nice. A math teacher uses delta math to assign work. On a recent test, 48% of his students passed the test. 83% of all his students used delta math. 78% of the students who passed the test also used delta math. Find the probability the student passed the test given they use delta math. So we are finding the probability of passing given delta. And that would be the probability of passing and delta over, look where that D is, the probability of using delta. All right, so let's do some substitution here with our numbers. Probability of passing given delta. It says 78% of the students who passed the test also use delta. So that's going to be a 78 up top. 83% of the students use delta, 83 down low. And let's just convert that to a percentage so the average person could comprehend it. 78 divided by 83 is 0.9398. So this would be 93.98% chance of passing given you practiced. Who would have thunk if you'd have practiced, you'd have passed? Who would have guessed that? All right, 3, assume A and B are independent. The probability of event A is 25%, 0.25. Probability of event B is 46%. Find the probability of A or B. Now, since these are independent, the probability of events A or B is just found by adding. And the probability of events A and B is found by multiplying. All right, so we can add them together here. We got 0.25 plus 0.46, which is what, 0.71? That seems legit. Multiplication, I'll probably use TI-84 for that. I don't know, maybe not. But I'll be dividing that by 4. What is it, 11.5? 0.115? That seems legit. We should probably check and go. 0.25 times 0.46. Yep, 0.15. All right, assume A and B have overlap. We're supposed to find the probability of event A or B. So the probability of event A or B is the probability of event A plus the probability of event B. Take away the probability of A and B. So I'm just going to plug some stuff in and go town with it. I got 0.4 plus 0.3, take away the and situation, which is 0.15. And 0.4 and 0.3 makes 0.7. 0.7, take away that, it's 0.55. It's 0.55. It's really hard to read. It's down there at the bottom of the screen. 0.55. Assume A and B have overlap. Probability of event A is a third. Probability of event B is a fifth. Probability of A or B is 1/10. Find the probability of A and B. So the probability of A and B is the probability of A plus the probability of B. Take away the probability of A or B. So we're just going to feed this thing again. That'd be a third. That'd be a fifth. And we're supposed to take away a tenth. Do you want to do it by hand? Are you special? Do you want to do it by hand? I feel like doing it by hand. So 1/3 would be 3/30. That ain't right. What's wrong with me? 10/30 plus 6/30, and then take away 3/30. That's the one I was thinking about when I wrote the first one. What I did is I established a common denominator, right? And you obviously do not have to do this by hand. You should, but you don't have to. 10 plus 6 is 16, take away 3 is 13. So I get 13/30. Now, I know you don't believe that, the human mind is capable of doing fractions. Just because you chose not to learn how to do it doesn't mean you can't do it. Watch me be wrong. Here I am talking smack. Watch me be wrong. Whew. I wasn't. Assume you have a deck of 52 cards without replacement. Find the probability of drawing an ace, a queen, a 2, another 2 in that particular order. So this is without replacement. The probability of drawing an ace would be 4 in 52. And then a queen. There's 4 queens, but you've pulled a card. And then a 2. There's 4 2s, but you pulled a card. And another 2. Now there's only 3 2s, and you also have, guess what? Pulled a card. It's that long string. And the way I'm reading this is an ace and a queen and a 2. And means multiplication, right? Let's see here. We got 4 over 52. It's almost a permutation. Well, it is actually a permutation to some degree. Any chance you can do this one? Yeah, I didn't think so. So it's 2.955 times 10 to the negative fifth. Let's go 9550. Which, if you like decimals, this means shift that decimal 5 places left, which is probably what I would do on your test. And there you go. Without replacement was the probability of drawing a red card and then a jack. Okay, so here's the deal on this one. This has 2 scenarios. The red card could be a jack. You got to think about this. So you got 2 scenarios here. You have the red card is a jack, or the red card is not a jack. You got to think about the scenarios. And those are the scenarios. Scenarios, however you say it. Tomato, tomato. It's really how that is. But there's 2 different situations here that can possibly happen. And you just got to think about that. So if the red card is a jack, so what happens here is you still got 26 red cards. Well, actually, let me rephrase that. If the red card is a jack, the odds of getting a jack would be 2 in 52. Now, you did pull a red card. So now there are only 25 red cards out of 51 left. Or the red card is not a jack. Okay. So you have 26 in 52 red cards. and then you have 4 in 51. And these two probabilities have to be added together. Kind of a tricky little question for most people, because you got to think about the different scenarios that are possible. And that is always an issue with probability. People don't want to think, they just want to do. Some kids have it, some kids don't. So I'm just typing in exactly what I wrote here. I didn't do anything special. Can you make her a fraction? Because I sure don't want to. You can. 77 in 1,326 chance of this series of events happening. All right, what do we got here? Billy, good old Billy. Billy is drawing 2 cards without replacement. What is the probability that he draws a queen and a jack if order does not matter? So that's kind of a big deal. There's no particular way in order, so he could draw a queen and then a jack, or he could draw a jack and then a queen. Now think about that. He could have a queen and a jack, or a jack and a queen. Notice that word or, which means add. So the probability of drawing a queen should be 4 in 52. Probability of drawing a jack would now be 4 in 51. Or he draws a jack, which would be 4 in 52, and then a queen, which is now 4 in 51. And you add those two things together. They're exactly the same, so I'm just going to, I'll show you what I'll do. So we got 4 in 52 times 4 in 51. These guys are the same thing, right? I really don't feel like writing it out. So I'm just going to add it back to itself. And that should be able to convert that to a fraction. It is 8 in 663. How long am I on this video so far? 12 minutes. All right, number 10, we got ourselves a table. It's got some given stuff in it, conditional and stuff like that. That's always good. You got to complete this table here, kids. And 29 minus 17 is 12. 12 plus 23 is what? 35. That's nice because I needed those two to add to 70. 70 minus 29, I feel like that's 41. And that's a total right here. So 41 minus 23 is what, 18? Easy peasy lemon squeezy. All right, so that's part 1, complete the table. Part 2, if a kid is picked at random, find the probability the kid is a left-handed boy. It doesn't mention the word given, so it's going to be out of 70. There's 70 total children. And a left-handed boy, there's 17 of them. Right, see, left-handed boy, 17 and 70. Find the probability of picking a girl given that they are right-handed. So I'm looking only at right-handed individuals. There are 41 right-handed individuals. It's going to be out of 41. 23 of whom happen to be females. 23 and 41. And part 4, find the probability of picking a kid given they are a girl or left-handed. So given that they are a girl or left-handed. All right, so there's 35 girls and left-handed. Now, how many people are actually in this group here? Because it's not 35 plus 29, because that counted the 12 twice. It's 35 plus 17, which is what, 52? It's out of 52, because you can't count something twice. Never, ever, ever count something twice. I don't like the way I worded this question. So now what do I pick? Picking a kid? I should say, and let's change the wording here, picking a right-handed kid. There we go. 23. 23. Weird, huh? But anyways, that's all I can do with that one. It wasn't worded right. 23 and 52. All right, number 11. Ooh, the Venn diagram. Consider the Venn diagram and answer the following probability questions. Of course, you've got to know how to read your notation, which I know you don't know how to do, quite honestly. All right, here we have the probability of F given D. So playing football given you're in drama, all right? So in drama here, let's add up the drama circle. We got 10, 33, and 31. That's what, 64? It's going to be out of 64. Now, how many of those kids play football? Looks like 10. And of course, that reduces. Those are both even. You know that. That's 5 30-seconds. All right, the probability of football union with, which means or, band. Football or band would be all those numbers right there. So you got to put some things together here. Let's see, we got 52, 60, 107, 100 and what, 26, 149. Let's check that again. 52, 60, 107, 126, 146. All right, so I came up with 146. There's 146 individuals there out of 180. What is that going to be divisible by? At least 2. That'd be what, 73 and 90? All right, here we have the word and. And. Part 3 is the intersection of F, B, and D. It's best read like that. It's the thing that they all have in common. And it's that right there. It's 2. It's 2 in 180, which is 1 in 90. All right, B and D, which means we play band and drama. Band and drama. There's 25 kids who are in both band and drama, so it's 25 and 180, which will reduce down to what? 536? That seems right. All right, part 5, the probability of drama or band. Drama or band. But not zero, which would be all that stuff, right? You just highlight everything here. But that's going to be out of 180. What do we have here? We got 60 there, 79. That makes 110, 133. Let's double check my math there. 52, 60, 79. I'll just do it different here. 102 plus 31, 133. I'm good with that. I don't believe that simplifies. And this says drama or band only. Only. You know, only. Does that mean no football? Drama or band only. So there are 73 plus 31, which is 104. Double check that. 73, I'm good with that. 104. 104 in 180, which is going to be even numbers. That's going to be 52 over 90, so 26 over 45. There you go. There's 11. Number 12, the number of employees who work nights and weekends at a department store is summarized in the table below. Let event N represent the event works nights. W represents the event works weekends. Based on the table are N and W independent events. So 2 events are independent if and only if probability of, and they're using N and W here, N and W is equal to the probability of N times the probability of W. All right. Let's see here. We're going to need a sum here. 8 plus 40 is 48. 12 plus 60 is 72. We're going to add down. We're going to get what, 120, I think. Seems legit. It's out of 120 people. All right, so what is the probability of doing nights and weekends? Nights and weekends. It looks to me like nights and weekends is 8 of 120. And it should equal the probability of working nights, which is 20 in 120, times the probability of working weekends, which is 48 in 120. So let's see if that works out or not. So we got our 20 in 120. Kids don't really like these types of problems. I've noticed that over the years. They're not actually hard. It's just something about them. They just don't like them. And is that in fact 8 in 120? They are. They're the same decimal, aren't they? So same fraction. So this is true. So because it's true, I'm going to let everybody see anything that has a no. Now, you know, they're using set notation here. Yes, because the probability of n times probability of w is equal to the probability of n and w. Choice 1. 13. The results of a survey of the student body at Central High School about television viewing preferences are shown below. Are the events student is male and student prefers reality independent of each other? Probably not. So the way this should be, the probability of male and reality should be the probability of male times the probability of liking reality. So the probability of being a male appears to be 230 out of 490. And I would say no, because if you'll look, you'll see there are men who like reality series. So I don't think they're independent, but we'll do the math. The probability of liking reality series is 180 in 490. And the probability of being a male that likes reality is 70 in 490. So we just want to see if these things are equal or not. That's the question. Are they equal or not? So see, we have 70 and 480, and I'm just being lazy here by crossing out the zeros. And then I have 23 and 490 times 18 and 49. You're probably sitting at home like, well, he's not typing in the numbers. I'm canceling the zeros out. That's what I'm doing, children. And they're not the same. So I got 0.1458, which is not 0.1724. So they are not independent. At all are they independent. Take me a small break and I will be right back. Don't be the kid who misses compliments, and I know there's going to be lots of you. The compliment is written one of two ways. It's usually written a bar, but if somebody's being lazy, they might use that, okay? But either way, it's 1 minus the probability of event A. That's all it is. So, anyways, I'm finding the complement of the probability of A or B, which would be written the probability of not A or B, with a bar over it. And it's simply 1 minus 3/5. Well, 1 is 5/5. And 5/5 minus 3/5 has been 2/5 forever. It always has been. The probability of A given B, well, its complement would be the probability of not A given B. And it's 1 minus 0.99, which is 0.01. You want to be extra fancy, you write that as 1 over 100. That's what it is. And then 3, the probability of not A is simply 1 minus 3/4. 1 is going to be 4 over 4, and 4 over 4 minus 3 over 4 is 1 over 4. All right, 15. Oh my God, the number of you that are going to miss 15. It is ridiculous, bro. You take the bell curve and you think about the rule. You got the mean. You go one standard deviation over left and right, where you add and subtract a sigma, you get 68% of the graph. Now, if you go 2 over, you get your 13.5s and your 13.5s. You put all these numbers together, you get 95% of the graph. You add in these little pieces right here, kind of ran out of room to go up, you get 99.7% of the graph. It is literally called the 68, 95, 99.7 rule. 1, 2, 3. 68% within 1, 95% within 2, 997 within 3. You do you, kids. Hopefully you like this question because it's something old. We'll find out. Actually, I need to pause and get a calculator ready, so I'm going to stop this video because I got to reset up a calculator. BRB, bro.